Okay, good morning everyone. Today we're covering Chapter 6, which is Telecommunications and Networking. So specifically in this chapter we'll be covering quite a few topics, specifically computer networks, network fundamentals, the internet, as well as network applications. So just to kind of start things off, I think it's important to kind of go over at a basic level what a network is. So a network is simply a kind of interconnected devices that communicate with each other. And there's some very important things that each network has, specifically the capacity. That is to say, how much data can go across the network at a time. One common measure of this is going to be bandwidth, which is going to be, at the SI level, it's going to be bits per second. Of course, in practice, you're going to see hopefully something larger than a bit per second. You'd probably see maybe kilobit per second, megabit per second, gigabit per second. Something like that to measure the bandwidth of the network. And that's basically how you can determine how much data can go across the network at any given time. So the FCC has a definition of broadband, which I believe is 25 megabits per second down and 4 megabits per second up. And basically what that is that's simply a way to determine the minimum speed of broadband service. Now broadband can also refer to using multiple things over a single cable. It really depends upon which definition you're using there, but for the most part, when you hear broadband, you can typically think of the FCC's definition. Now you also have latency, and as we talked about last class, latency is going to be the time from when you send out something until you receive a response. It's going to be measured in milliseconds. Anything above 100 is kind of high. Anything below 100 is probably not going to be noticeable, at least not very noticeable, because you're talking a fraction of a second when you're talking about sub 100 millisecond. Okay, so now I want to go over some of these types of networks. Now, you'll notice that two of them have an asterisk beside them, and that's because those are the two that you'll be tested over. The others, you will not be tested over. So I'll just go through them all, though. And when I say that you'll be tested over them, you may very well see them as other answer choices. I don't think you will, but you might. So make sure that you're kind of aware of what they all are, but in general, the answers to the questions will either be local area network or wide area network. So just kind of start at the most basic level up here. A personal area network is going to be a network that's going to be very close to one person and also to only a few devices. So when you contrast things like local area network with personal area network, can be kind of difficult to do because if you have more than 3 or 4 devices, you're technically outside the definition of a personal area network and moving more towards the definition of a local area network. So typically when we think of a personal area network, you may think of a desktop computer or something that interfaces with maybe a smartphone and possibly a printer. And that's basically the extent of it. A local area network is quite a bit larger, covers a building, could be a residence, could be an apartment, could be one office building, but the whole premise of a local area network is that the traffic is not leaving the building except for internet, of course. So all the devices communicating are doing so within the building. That contrasts with a wide area network. A wide area network can encompass multiple buildings. A campus area network, again, is very similar to a wide area network in that it can basically be company-wide. So it doesn't even have to be limited to a geographic area. Certainly with things like VPN, doesn't have to be at all. So just kind of keep that in mind, is that a campus area network is for a company, for a campus of some sort, maybe for a large corporation, whatever the case may be. That's kind of what we're seeing with a campus area network. And then lastly, a metropolitan area network is very similar to a campus area network in that it's for a very large metropolitan area. These are often seen when some sort of a metropolitan area establishes maybe a Wi-Fi network for everyone to use. I believe New York may have done something like this a couple years ago, where they set up Wi-Fi hotspots throughout the city. That'd be a metropolitan area network. It covers a large geographic area, but it doesn't cover multiple cities. So again, you can kind of see, based on this, why I'm only going to focus on local area network and wide area network. And the main difference is in a local area network, all the traffic, apart from the Ethernet traffic, is staying within the building, whereas a wide area network encompasses multiple buildings. And of course, as we talked about last class, one way we could kind of incorporate some of this and allow multiple buildings to communicate with each other is using broadcast media. We talked about using a microwave in particular. That'd be perfect for a wide area network establishment. We see these quite a bit for schools may use them. Universities may use them to connect buildings that are far away and impractical to string a cable between them. Or I say string, you could also bury the cable, of course. There's lots of options. So that's pretty much what you need to know. Like I said, I'm glancing over to make sure there's no questions or anything. Okay, so let's talk more about enterprise networks. So I think the first thing that's important to talk about with enterprise networks is that there's no one enterprise network. If you go work at a place, they could have their network configured completely differently from any other place. So I'm going to focus in terms of general enterprise networks. And of course, the goal of an enterprise network is to kind of enhance communication, enhance collaboration between various functional units within an organization. There has to be a business purpose to this, otherwise they wouldn't use an enterprise network at all. So large firms receive benefit from this in having devices be able to share files, to have meetings afar, to be able to monitor employees. That's something a lot of enterprise networks have, is some sort of monitoring technology, maybe through the firewall, maybe through applications that are installed by the network administrator. There's lots of different ways to do things. So that's kind of one of the bigger things. But, they're all going to be laid out somewhat similarly, and we'll see an example of this in the next slide. And again, this is not a networking class. I don't expect you to memorize every single topic. However, there is going to be some things that are going to be important. So when we talk about an enterprise network, typically we're going to have some sort of backbone connection. And this backbone connection is going to have either a border router, or it's going to have an edge router, something that's on the edge of the network. Typically it's going to be called a border router. And that router is going to be what is going to communicate with the outside world. All the traffic going to the Ethernet is going to go through that particular router. And of course, you'll also have a firewall, hopefully, kind of helping to filter some of that traffic and keep a lot of attacks from materializing on the local network. So that's pretty much some of the basics. It's going to be inside the backbone. And you could have endpoints be connected via Wi-Fi access point. They could also be connected via a physical cable. So there's a lot of different ways to do things. One thing that a lot of enterprises use is a technology called radius authentication. And the whole purpose behind this is to allow for each individual user to have their own password to connect to the network. That way you have more control over your network in terms of making sure that each user is doing what they're supposed to. If we didn't have this technology, it'd be pretty difficult to do a lot of network security, because we'd have to open it up to everyone, and changing passwords could be quite difficult for an organization of maybe 100,000 people. Some organizations even have millions of people. Think about Walmart. Of course, I don't know if Walmart has internal wireless networks or not, but they have millions of employees, and it would be quite problematic to have a network unless you had it tied to the user. So think about on campus we have the campus network, and that's using IEEE 802.1x, which is the standard behind radius authentication. So when you sign on to Eduroam, you're actually using your Mississippi State user account for connecting to the network. So that's pretty much what radius authentication is. It's a very important technology, and it's something that a lot of enterprises are using. Now, if you're at a, let's say a business of 5 people, they may not use this sort of technology. It could be, it's going to be more complicated than standard WPA2 authentication. but it is more secure, and it does allow for greater flexibility and greater management control. So it's something that's probably going to be used at any large organization. And then another thing that's pretty consistent among any sort of enterprise network is the idea of having redundancy. It's not uncommon if you're purchasing equipment for an enterprise network to go ahead and double up the equipment, even if you don't ever turn it on. Of course, in most cases you turn it on and configure it, but that's a different story. It's not uncommon to have 2 of every component you need. And if they're cheap enough, you may even have 3 of every component you need. Because downtime can be quite costly to an organization. When you consider, all the things that go across a network, it's not uncommon to lose, 1 or 2% of your traffic. That could be pretty devastating. So you want to have redundancy in case any equipment malfunctions. Maybe there's a problem. And this goes beyond just the equipment itself. If you think back to one of the earlier chapters, we talked about some of the disasters that could happen. I believe it was the information security chapter. And we talked about things like fire, we talked about things like losing power. It's not uncommon to have redundancy to the level to where you have multiple internet service providers, you have multiple power sources, you have multiple cables running through your building in different places. It's not uncommon to have that in an enterprise network setting. So I think I've talked enough about that. Let's see an example of one. Now again, this is not what you would see in every single organization. I'm not saying that, but in general, you're going to see something that looks pretty similar to this. So here, it's laid out to where they have the core in the center, and that's going to be where your Ethernet service comes in. It has your border router, it has your firewall, all that's going to be inside the core. And what it's going to do is it's going to send those out to distribution points. And these distribution points are probably going to be located at least one inside of a building. And from the distribution point, it's going to have cable runs that go out to the access points. Maybe it goes out to individual devices, if you're talking wired. But basically that's what you see. And what's important to note is that there's redundancy built into this network pretty heavily. So there's 2 stacks of core equipment. There are dual stacks of distribution, and it looks like you can tell there's wires going from each of these. Now, I wouldn't say this is common to have at the distributional level, but at the core level that is pretty common. At the distributional level, it depends upon which part of the network you're discussing. If you're discussing the part that houses the servers and houses e-commerce activities, yeah, you're probably going to see a lot more redundancy. But if you're talking about, let's say accounts payable, they may not have this level of redundancy to where they have, 2 different cables going into a single device. That's pretty rare. And in fact, most devices wouldn't even support that. Even a lot of enterprise-grade devices wouldn't support dual input for, individual users. But some do. And again, as we're talking about, a server, it probably would. If we're talking about an access point, it may. But if we're talking about a desktop computer, it almost certainly will not. So, but this is kind of here to show, some of the basics of how this would work. Again, you'll see different, you'll see this done differently depending upon where you are, where the business is, that sort of thing. Okay, so let's kind of talk briefly about how you would actually go about establishing the connectivity. Well, it's going to go across some sort of a communications channel. And we talked last class about a lot of different types of broadcast media, that is to say, wireless networking. This class we're going to focus more on the cable media side. We will still kind of touch on some of the broadcast media. And when we say cable, of course we're talking about a physical cable where a signal can pass across it. And when we talk about broadcast, of course we're talking about wireless signal, where there is no, you can't touch the thing. Well, I guess you could, but you get what I'm saying. There's not a cable that's directly passing the signal from the device. So that's the distinction there. So speaking of cables, I'm going to disagree with the book quite a bit on a lot of what they say about cables. Each of these three types of cables can generally go about 300 feet without being powered. The exception to that is fiber optic cables. Certain fiber optic cables can go far longer distances without being powered. However, not every single spec of fiber optic cable can. In fact, you can make the argument some twisted pair can go longer than 300 feet. Same with coaxial cable. Each of these can go longer depending upon the spec of the cable. Generally speaking, it's best practice to power the signal. And what I mean by power the signal is, so if you're doing a run of cable down, let's say a 500-foot hallway, what you would do is you would put some sort of a powered switch where you put in the, maybe at 250 feet, you put a powered switch, and that just helps to kind of reduce any sort of signal loss from that distance of cable. Because if you're sending a signal over that length of cable, you could certainly run into a case where this signal is going to be degraded over time. Again, it depends on a lot of different factors. I'm going to disagree with the book when they talk about a lot of these differences in length, because there are going to be best practices with each of these. And it depends very specifically upon the individual spec of each cable you're using. So that's just something to get out of the way there. You probably see a test question regarding which cable is most likely to be able to have a signal transmitted more than 300 feet. The answer to that would be fiber optic, because fiber optic has a lot more individual specifications for cables that exceed 300 feet. But you could certainly see a case where a twisted pair can go, say, 600 feet, and coaxial can go, say, 900 feet. That can happen, and it does regularly happen, but it's more regularly that you have fiber optic that can go a long distance. So let's talk a little bit more about each of these, though. Just want to get that out of the way. So twisted pair is what you think of when you think of a traditional Ethernet cable. If you were to take one and chop it up, you would actually see that there's going to be 4 twisted pairs, each having 2 wires twisted. Now, depending upon which spec of the cable you're using, those twists may be more or less frequent. Generally speaking, the lower spec of the cable that you're using for twisted pair, the fewer twists each twisted pair has in, say, an inch or two. Newer specifications like Cat 6, Cat 7 have a lot more twists, and I'm not going to get into the physics behind it for obvious reasons. But, in general, though the more twists there are, the faster that the data is able to flow through the cable. So what you see is that with higher spec cable, it's going to have more twist inside a twisted pair. Now, of course, I'm not going to test you over that. And another thing I disagree with on the book, when they talk about the cable speeds, there is no single speed of twisted pair. There is no single speed of coaxial cable, and there's no single speed of fiber optic. You could find twisted pair that's only capable of doing 10 megabits per second, and you could find fiber that's capable of doing 100, probably at least 100 gigabit per second. But you could also find fiber optic that's only capable of doing 100 megabits per second. So there is no single answer for which one is going to be faster. I will say that fiber optic in pretty much all cases is going to be substantially less latent in the connection. And that's simply because of the way that the signal is being transmitted through the fiber optic cable. So, of course, fiber optic implies that it's traveling as a light signal. And if you actually had a piece of fiber optic cable and you sent a signal through it, you'd be able to look at the other end and you'd be able to see the light. Whereas twisted pair and coaxial are going to send it via electrical signal, which of course is going to be subject to a little bit more degradation as it goes. But again, that's not to say that it will always be. So there's a lot of differences in the individual cable specification that you're using. So again, fiber optic, it does have other advantages as well. Because it's not using any sort of electrical signal, it's using a light signal instead. It has lower latency, and it also is not subject to interference. Both twisted pair and coaxial cable can be subject to interference, However, you could get around that pretty easily by simply using cable that's shielded. Cable that's shielded for using it in those exact situations. For example, a lot of heavy fluorescent lights can cause interference with unshielded twisted pair cable, but you could easily get around that by using shielded cable. So again, I'm going to disagree pretty heavily with what the book says. They have a little chart, I think it's table 6.1, where they go through the advantages and disadvantages. It highly depends upon the specific cable, let me just say that. But that kind of covers the differences in cable. And again, if you're interested in this, certainly look at individual cable specifications. Look from Cat 3 to Cat 4 to Cat 5, Cat 5e, Cat 6. Compare each of those. Don't just don't look at these as being something that's going to be standard throughout the entire. The only thing that's really standard is, again, fiber optic is using light, whereas coaxial and twisted pair are both using electrical signals to pass the data through them. That's the only thing that's really standard, comparing them. Everything else highly depends upon the standard. Okay, so with that out of the way, that's a lot of information there. Talk a little bit about network protocols. So basically, we have the Ethernet protocol, and that allows us to communicate on the internet. And one of the main protocols associated with this, of course, is TCP/IP. I don't have a lot of test questions on this, but basically just know that TCP/IP is what allows the information to go across the network in a standard fashion. Of course, when we're talking about web pages in particular, we have the Hypertext Transfer Protocol, and that's something that's built in to where your web browser will correctly interpret the pages and display information in a pretty standard way. So of course we have HTML to kind of help with making sure that the web page looks okay, but in general your web browser is going to handle all that. You don't have to worry about it. So getting a little bit more specific, luckily for everyone, I'm not going to make you memorize this, but this is the OSI model that actually kind of models how TCP/IP transmits data across a network. So basically it's designed to where it's 7-layer process. So what you have up here, it's not shown and it's not really part of the OSI model, but the 8th layer would be the user. So the user uses an application which has the session associated with it, goes down to transport. This is where the data is actually split up to form a single packet, which is happening in the next step, of course. The packet then gets the IP address it's going to and coming from, and then it's going to be put, this is going to be done at the router level where it's going to the specific device, and then finally it has the physical layer, and that's where we actually see how the data is being transmitted physically. How is it moving from one spot to another? That's where we talk about things like the signal, the actual binary information within the packet, because at the at the end of the day, each packet has binary associated with it. That's what's actually being transmitted. You don't see that as the end user. You see it presented inside the presentation layer and given to you in the application layer. But that's pretty much what we see. So again, you're not going to be tested over this other than maybe knowing that the OSI model models this. You're not going to have to know any of these individual layers, but it's a cool thing to know. I think it's pretty interesting to see. Hopefully you feel pretty similarly, but if not, that's fine too. Okay, so we're going to shift gears a little bit. We talked about some of the basic networking technologies. Now we're going to talk about network processing. And this is a very important topic because this covers quite a bit of information that's going to be transmitted over a network. Why are we transmitting information over a network? Well, there's a couple reasons why we may do that. We may do that to do processing. And when I talk about processing, what I'm talking about are basic tasks like file storage, basic tasks like web browsing. All that's what I'm talking about with processing. And it could also be tasks like running applications. So there's two major ways to do network processing. There's going to be the client-server approach, and there's going to be the peer-to-peer approach. Now, the difference between these two is going to be the client-server approach is going to use, there's not going to be, let me put it this way, there's not going to be the same amount of power involved between the devices. And when I say power, I'm talking about authority. So the client is going to have less authority than the server. The server will have more things that it can do. It'll have more access rights. It'll have more, basically just more things associated with it. Whereas peer-to-peer, there is no device that has more authority than another. So for example, if we're doing peer-to-peer computing tasks, I have just as much say as someone else who's doing the same task regarding how the task runs. So that's something that I think is important to note. So with the client-server approach, what you have is you have individual clients that connect to a server, and the server does things like, maybe it does things like file storage, maybe it does things like print service, maybe it does things like gives them a web page, maybe it allows them to download a file from it, whatever it allows them to do. That's what we're talking about with the client server, whereas peer-to-peer, so it's pretty decentralized. There's not going to be a central authority or a server that dictates what happens. It kind of happens more organically in a way. This is used a lot for things like file sharing. We have sites, some of them questionable legality, of course, where you can go and download content using peer-to-peer. What happens with those types of file sharing, particularly things like torrents, is that you're actually downloading it from maybe dozens of other people at a time. They're sending you information, and in return, you're sending it to other people who don't have the same stuff. So that's kind of what we're talking about, whereas client-server, you'd be downloading it from a single server, or at least a single entity servers. It won't necessarily be one server all the time. So with that out of the way, let's talk a little bit more about that. Specifically, there are three major types of the client-server relationship. There's going to be the zero client, there's going to be the thin client, and then there's going to be the fat client. And depending on which approach you're looking at, you could also see a fourth one, which would be the chubby client. And what each of those terms represent is they represent the amount of processing that's done on the local client machine versus the server. So again, these are not terms I made up or anything. I guess they could be kind of offensive, but these are technical terms. It's important to note. So with a zero client, there's not really any local processing done. So basically we can think of this as a terminal, where all that you're doing is you have a mouse, a keyboard, and a display that's connected to a server, and the server is doing every bit of processing. It's even doing things like running the operating system. It's doing things like handling all the video that you're doing, and that's all done on the server. Now a fat client does most things on the local individual client. So if we're running a fat client machine, we might connect to a server just to download a web page, but most things, including the operating system, including the applications, they're all running locally. So we're using the server for a very minimal thing. A thin client is going to be somewhere in between a zero client and a fat client, where probably more of the tasks are done on the server, but some things are going to be stored locally. So when we compare the hardware associated with each of these, we often see that a thin client has maybe 16 gigabytes of storage locally, maybe 32 gigabytes, in some cases even 64 gigabytes. It depends on which thin client you're purchasing. But there are going to have some local storage. Maybe it's used for caching, maybe it's used for doing a net boot, whatever the case may be. You're going to see some evidence that there's going to be a lot more local processing done than there would be on a zero client. Zero clients typically have a very small amount of onboard storage, because the processing, basically what it's doing with the onboard storage is telling it point to this server and display what this server is displaying. That's basically the difference there. Let me know if there's any questions about any of this. But again, you pretty much just, as you go from zero client to fat client, you're doing more processing locally. So if I were to ask a test question, I would probably make it to where it's pretty clear that there's either 99% of the processing being done locally, in which case it'd be a fat client, or I'd say almost none of the processing is done locally, in which case it'd be a zero client. Because it's kind of difficult to say what percentage a thin client is. To distinguish a thin client from a zero client in particular, it's pretty different. In fact, not every manufacturer recognizes the term zero client. So they may sell something that some manufacturers would consider to be zero client, while other manufacturers would not. But in most cases, thin clients and zero clients are somewhat going out of style in the business computing world and being replaced with more local processing. But again, that's highly industry specific, and that's company specific, to be honest. Some companies think that zero clients and thin clients are great because there's very little local management that has to be done. When you compare a zero client to a fat client, think about the amount of moving parts. The fat client has a lot more processing ability locally. So with a zero client, it may not even have a single internal fan. It may not need them. Could use a very low voltage processor that only really has to be capable of doing very minimal tasks, whereas a fat client, again, it's doing things like running the operating system, running any applications, running web browsers, running everything locally. So from an IT perspective, it's a lot easier to manage zero clients than it is to manage fat clients, because you can do everything centrally. If the user is having a problem, it's probably not the hardware with a zero client, because it's so reliable, because it's A, so low powered, B, doesn't have much heat associated with it. Just needs a lot less maintenance done to the actual device itself. So like I said, let me know if there's any questions about that. Normally I'd have a quick little video here. It's kind of humorous, but again, it's not my video, so I can't really stream it over YouTube. But certainly it's a funny little video to watch sometime. Okay. So we've talked a good bit about network. We've talked about some of the different types of client-server relationships. Now let's talk about types of actual nets. So I have three listed here. I have the intranet, the extranet, and the internet. So, first let's talk about what an intranet would be. And that's the first one here. It's very difficult to make them sound very different. But I'm just going to go through, talk about intranet first, extranet second, and internet third. So an intranet would be a company establishing an internal network to share maybe files, to share whatever they're sharing. Basically, it's a network that's designed to share files within a single company. That's going to contrast with an extranet. An extranet is going to still be somewhat of an internal network, but it's not just going to be internal within the organization. It could be internal within maybe a group of organizations. Maybe it's internal within, say, Southern universities. Maybe they have an extranet set up to where maybe people can share things like research articles. Maybe they can share, course files, that sort of thing. That'd be an example of an extranet, where there's some grouping. It's not all within one organization, but you still have to be a member to access it. Okay, internet is different from both of those. Whereas intranet and extranet both require membership in something, be it an organization, be it a professional group, something like that. Internet, anyone can access, and it's freely available, as long as you have internet service, of course. So that's the three major types there. Okay, and it can be used for many things. We talked about the internet. It can be used for things like communicating with others. Right now I'm streaming on YouTube. That's communication. Could also be things like using email to communicate, using Skype, those sort of collaborative technologies. And speaking of collaboration, I just mentioned Skype. Of course, there's many other meeting platforms that you could use. You could also use things like collaborating in gaming. If you want to use something like Discord to communicate with a friends group, that could certainly be done as well. Entertainment, again, I just mentioned gaming. That's one use. device, or not the device, but the platform I'm streaming on right now, YouTube, has a lot of entertainment. I don't know if you'd find my content that entertaining. That's kind of a personal thing. Maybe you do, maybe you don't. But hopefully you find it educational, because that's an important thing as well. Particularly right now where almost every single school in the country is, using the internet for education. Putting a lot of content online, putting exams online, that sort of thing. And then lastly, of course, the internet can be used for research. You could certainly go and research pretty much any topic you wanted to, get a lot of information, get a lot of different perspectives on things. It really is like having access to every single newspaper, every single encyclopedia, really almost anything that's ever been written you can find on the internet. Not everything, of course, but a lot of things. So that kind of wraps up how internet's used. So today we talked about how computer networks are used. We talked about some of the basics for enterprise networking. Talked a little bit about the internet as well as some applications of it. Let me know if there's any questions. I do want to have some brief reminders before we completely wrap up. This is the last lecture. Next Tuesday we will have a course review. So before then I will finish up the final exam, and I will send you all a list of every single topic that will be covered on it. Certainly it's an important exam. It can replace your lowest test grade. If if it helps you, it'll replace one of your test grades. Basically that's all that needs to be said about that. So the exam will cover everything that was covered in the course. But like I said, you'll have a list of the topics you can go through if you don't remember something. Come to the review, ask me. Certainly happy to go through them. Also come to office hour, that's fine as well. But there's really only going to be one more office hour after this office hour coming up here. And that is, of course, going to be after the final. But like I said, email me if you have any questions. Happy to address them. Final, of course, we'll talk about that more next class. But that's pretty much it for the semester. You should have gotten an email, I think about a week ago maybe, regarding teaching evaluations. I'd certainly appreciate if you'd take the time to do that. Shouldn't take more than, however long you want to spend on it, I guess. Probably 5 or 10 minutes per class. I know that your other instructors would also appreciate you all doing those. But apart from that, I've certainly enjoyed it. Hope you all have too. Let me know if there's any comments. I'm going to hop over to Teams and have a quick office hour. But apart from that, hope you all have a great day.